Welcome to this part. In this video, we are going to talk about the rationalization techniques and some of the limits that have a certain pattern of evaluation. In the last video, we talked about reduction of power and the use of L'Hopital's rule. If you haven't watched it, kindly click on the more in the description below and scroll down to calculus playlist. So click on it and you will be directed to the playlist where you can watch all videos on calculus. Now let's move on to how to use rationalization techniques. These techniques applicable to those limits that have radical. So let's start with example 1. When we have limits when x tends to 1, square root of x minus 1 over x minus 1. You can see that numerator have a radical, so and the conjugate for this will be square root of x plus 1. Now rationalize. So we have limit when x tends to 1, square root of x minus 1 over x minus 1 times square root of x plus 1 over square root of x plus 1. So you can see that the numerator when multiplied together is different of 2 square. So we will have, this will be by multiplying them together. So we have square root of x minus 1 times square root of x plus 1 over x minus 1 times square root of x plus 1. So the numerator is different of 2 square. So we have limits when x tends to 1. Since we will have square root of x raised to power 2 minus 1 raised to power 2, so we will have x minus 1 over x minus 1 times square root of x plus 1. Then x minus 1 will cancel each other. So it will left limit when x tends to 1, 1 over square root of x plus 1. So this will be by substituting 1. 1 over 1 plus 1, and this will equal to 1 over 2. Thank you. Let's move on to the second example. So example 2, if we have limits when x tends to 0, 2 square root of x minus x over square root of x. So for this one, you can see that in the denominator we have square root of x, and this will be very easy for us to use for our rationalization. We will have this, then so our limit will be 2 into square root of x minus x times square root of x over square root of x times square root of x. This will be x. Now let's multiply it. So we have limit when x tends to 0. This will be 2x minus x root x over x. So we can factorize x out of this expression. So we have x into 2 minus root x over x, and this x will cancel out x. Then this will be limit when x tends to 0, 2 minus square root of x. By substituting now, we have 2 minus square root of 0. So our answer is 2. Next example, when we have limit when x tends to 0 for square root of 4 plus 3x minus 2 over 5x. Now for this, numerator is a radical, so conjugate will be this, and then let's multiply it. So we have limit when x tends to 0, square root of 4 plus 3x then minus 2 over 5x times the conjugate square root of 4 plus 3x plus 2 over square root of 4 plus 3x plus 2. Now let's multiply them together. So we have limit when x tends to 0. The numerator will become different of 2 squares, so we will have this minus 2 raised to power 2. So 5x into square root of 4 plus 3x plus 2. Then this will become The limit when x tends to 0, 4 plus 3x minus 4 over 5x into square root of 4 plus 3x plus 2. Then 4 minus 4 is 0. So x will cancel x. And then our limit will be limit when x tends to 0, 3 over 5 into square root of 4 plus 3x plus 2. Now let's substitute. We'll have 3 over 5 into square root of 4 plus 3 into 0 plus 2. And this will be 3 over 5 into square root of 4 plus 2. Square root of 4 is equal to 2. So our answer will be 3 over 5 into 2 plus 2. So this will be 3 over 20. Hope this is clear. Thank you. Now let's talk about the last techniques of evaluating limits, which is in form of pattern, or we can call it a formula. Now let's take note of these formulas. For limit when x tends to 0, sin x over x is equal to 1. 2. The limit when x tends to 0, cos x over x is equal to 0. Third one, for the limit when x tends to 0, in brackets 1 plus x raised to power 1 over x is equal to e. The fourth one, limit when x tends to infinity, for 1 plus 1 over x raised to power x, this is also equal to e. And the fifth one, the limit when x tends to infinity, x raised to power 1 over x is equal to 1. Please take note of these formulas. We'll be using it. Now let's have some examples. The first one, limit when x tends to 0, sin 4x over 4x. Remember that limit when x tends to 0, sin x over x is equal to 1. So let's make u to be equal to 4x. Then we will have limit when x tends to 0, sin u over u. And this is the same thing as the formula. So we can use the pattern now. So this is equal to 1. Now, another example. Limit when x tends to 0, sin x over 3x. For this, we have factors of 3 at the denominator. Let's factorize it out. So we will have limit when x tends to 0, 1 over 3 times sin x over x. And sin x over x is equal to 1. So our answer is 1 over 3 times 1, which is equal to 1 over 3. Now let's move on to another example. Example C. The limit when x tends to 0, sin 5x over x. For this, we have factors of 5 at the numerator. Therefore, this will be multiplied by 5 over 5. So our limit will be equal to 5 sin 5x over 5x. So sin 5x over 5x is equal to 1. So our answer for this is 5 times 1. So which is equal to 5. Hope you are getting it. Now let's solve another one. Limit when x tends to 0, sin 2x over sin 7x. Whenever we see a question like this, just multiply x over x, then followed by 2 in the numerator, and this will be 2 over 2. And the denominator us as well. This will be times 7 over 7. And this make no change to the expression. Now let's arrange them to our favorite pattern. So for sine 2x, we now select 2 in the numerator and 2x for the denominator. So we have 2 sine 2x over 2x multiplied by, for the sine 7x, we will now select 7x at the numerator and 7 for the denominator. So we will have 7x over 7 sine 7x. Now, if we look at it closely, we will notice that sine 2x over 2x is equal to 1. And for this is the same thing as sine 7x over 7x raised to power minus 1, which will equal to 1 raised to power minus 1. And this is equal to 1. Therefore, this will be 2 over 1 times 1 over 7. So our answer will be 2 over 7. Thank you. Let's have another example now. For the limit cos 7 over x when x tends to 0. We have factors of 7 in the numerator, so let's multiply it by 7 over 7. So this will be limit when x tends to 0, 7 cos 7x over 7x. And cos 7x over 7x is supposed to be equal to 0, because limits when x tend to 0 cos x over x is equal to 0. Therefore, this will equal to 7 times 0, which will equal to 0. Now, let's have another example. For the limit when x tends to infinity, 1 plus 1 over x raised to power 5x. For this, remember that limit when x tends to infinity, 1 plus 1 over x raised to power x is equal to e. So let's make our question to have the same pattern. So we will have limit when x tends to infinity, open brackets, into brackets 1 plus 1 over x raised to power x, or raised to power 5. So in the brackets, this is the same thing as e. So we have e raised to power 5. Now let's move on to the next example. For the limit when x tends to infinity, into brackets 1 plus 2 over x raised to power 3x. For this, we have 2 over x instead of 1 over x. So let's multiply the power by 2 over 2. So we will have limits when x tends to infinity, into brackets 1 plus 2x. Now we will make the power to be inverse of 2 over x. Therefore, the power will be x over 2 multiplied by 3 times 2 is equal to 6. So we can now see that we are now have a pattern. So our answer is e raised to power 6. Hope you get it. Thank you. Let's move on to the next example. So limit when x tends to infinity, 1 plus 1 over 4x raised to power x. For this, we will have 4 at the denominator. So let's multiply the power by 4 over 4. Then our limit will be into brackets 1 plus 1 over 4x raised to power 4x multiplied by 1 over 4. So this is the pattern. So our answer will be e raised to power 1 over 4. Now let's move on to the next example. Now, limit when x tends to infinity, 3x raised to power 1 over x. So remember that limit when x tends to infinity, x raised to power 1 over x is equal to 1. But in our question we have factors of 3. So let's multiply the power by 3 over 3. So our limit will be limit when x tends to infinity into 3x all raised to power 1 over 3x times 3. So 3x raised to power 1 over 3x is also equal to 1. So therefore our value will be 1 over 3. This is equal to 1. Actually, we can use a direct substitution where 1 over infinity will be equal to 0 and then our value will be 1. Now let's move on to the next example. The limit when x tends to 0 into 1 plus 3x all raised to power 1 over 2x. Now remember that limit when x tends to 0, 1 plus x raised to power 1 over x is equal to a. Therefore, let's make our question to be look the same. Now we have factors of 3, so let's multiply the power by 3 over 3. So our limit will be 1 plus 3x all raised to power 1 over 3x times 3 over 2. So we can now see that this will be equal to a. Now our answer will now be e raised to power 3 over 2. Thank you for watching. Please don't forget to check the description below to have access to the calculus playlist, and don't forget to subscribe to this channel if you are not do so. Thank you. Meet you in the next video.